In this video, I'm going to show you how to alter your axes in Ada and also label them. So this is just an example data set which lasted quite a long time, over about 300 hours, where I was growing spirulina and I was ramping up the red light as I went. So I'm first going to talk about how I might alter this axis here. Right now it's telling me how long the experiment was in seconds, which isn't particularly helpful. The default actually for Ada is normally hours. So I'm going to go into my axes, select hours, and I can change it. If I don't even want hours, I can change it to days. And Ada will change this axis for me really quickly. So it's really easy to do. If I wanted to, just look at the point of the curve where, I don't know, before I hit this top bit here, I can do so. So it's like it was about 100 and, let's do it to about 170. I can do that really easily by setting the minimum and the maximum of these units that I want it to read. So I believe it was about 170. And it will just put that part of the curve for me. And if I want to manually change the labels, I just say here what this is. This was a time as my label, my unit was hours. So Ada has automatically done this for me, but there you go. You can see I can change that very easily here. I'm now going to talk about this axis. So here I've actually got, I've calibrated my optical density dataset with a standard curve, and CD just means that this is my calibrated data set. If you have no idea what I'm talking about when I say standard curve, this is one I've loaded in. Please see my video about standard curves and Ada. So this is my standard curve one, great, but let's say I actually do want to look at what my raw optical density reading was over the course of the experiment, so I'm going to get rid of this range here. I just click this drop box and select OD. And then I press plot, and you can see this axis has changed. If I want to, instead of presenting the raw optical density or the calibrated curve optical density dataset, I can plot my data in a log scale by selecting that box. Or if I don't like that scale, I can use this, which is basically a log scale. And you can see it will plot like that for me. Again, in a similar way to my x-axis, I can specify the range which I might want to display my data. So let's say I want to show it between 0.2 and 0.4. It will just show me that, which looks pretty strange, but it is possible. So it's just cut out all of the readings between those axes, between those readings. Finally, this axis, my Y2 axis, I can change. So this is Algebra Pro data that I'm using, so it measures all these different things. Right now it's measuring my red light, but let's say I want to display what the temperature was. I just select it from this drop-down menu, select plot. Now often these measurements can be quite noisy, so it's quite easy to deal with this. You just go into your data tab and select a time window here for your condition data time average, let's say of 10, and Ada will just take the average of whatever your condition data was and plot that for you. So here I believe this should be plotted in standard deviation, which is the standard. Yeah, so you can check that in your stats tab, or you can swap to standard error depending on however you'd like to show your errors. Let's go back to plotting tab. And yeah, that's basically all there is to it. Again, with your temperature, if you want to change this axis, it's very easy. Let's say we want to just look at the temperature range between 29.6 and 30. We just go back to the axis, select 29.6 and 30. and it will show us the temperature between those specified units. So the temperature looked pretty constant actually. Finally, a bit about labeling, because Ada uses LaTeX for its special characters. So as an example here, for my optical density growth curve or calibrated density readings, I often like to show it as OD, and then in subscript I like to mention the wavelength that I'm using. So in order to get LaTeX, in order to get Ada to recognize this, I have to use the LaTeX command. So for using a subscript, you normally have to use these $2 symbols, which are the LaTeX, tell LaTeX that it's going to be a maths symbol, it's going to be in between them. You then do an underscore, and then put whatever you want to have as a subscript in those brackets. And then that should work. Let's replot and show you. Temperature, again, that's a special symbol. And so I've just got an example here of some of the special commands that you want. So this is one I just did for getting my OD into subscript of 750 wavelength. But for light, to get your mu and u, you use this. So you do a backslash and a mu. And so to write this here in bold, this is the symbols that you have to do. I'm putting these at the bottom of this video in the description, so you can just copy and paste them if you need to quickly do this. And for temperature, you need to use again, this special symbol between the dollar signs, circ, and that will give you that little button there. Okay, and I think that's everything that you need to know. I suppose finally, if you want to change your title, you just do it at the top here. Thank you.